Hi guys, what's up? I am Dinesh. Welcome you all to the online lecture. In this lecture, we are going to discuss about the most important concepts of the chapter matrix and determinant, which is nothing but the eigenvalue and eigenvector problem. Okay, so this eigenvalue and eigenvector problem is very important of this chapter, and it is useful. It is useful in classical and quantum mechanics also. So it is also help to find the characteristics polynomial of a matrix, and it is also help to diagonalize a matrix, which is later on very important for physics students basically. Okay, so let's see how to find the eigenvalue and eigenvector of a matrix. So let's see these concepts what are here. Let A be any n cross n matrix and x be a column vector of order n cross 1, considering the equation Ax equals to lambda x. What it says, let A be a n cross n matrix. This is your A, say this is your A, and x is your n cross 1 matrix, and this is also your x n cross 1 matrix. If it's an equation, and if this equation is satisfied for the value lambda, here the value lambda, if this equation is satisfied for the value lambda, then lambda is called your eigenvalues, and any non-zero x, x is your nothing but your column vector, any non-zero x column vector satisfying this equation is called your eigenvector. Okay, this is very basic concepts of this eigenvalue and eigenvector problem. Okay, so from these equations Ax equals to lambda x, I just rewrite it as Ax equals to lambda Ix, because I is your identity matrix of order n cross n, which also result it as a column matrix of order n cross n. So from this, if I take it left side, I can write it as a minus lambda I into x is equal to 0. Here I have already said this x is your non-zero column vector. That's why this part of the equation must be equals to 0. Here you can find the value of lambda to get the eigenvalues of a matrix. Okay, so how to find this a minus lambda I? How to find this a minus lambda I? Okay, so to find a minus lambda I for any matrix A, just subtract lambda down the main diagonal. I will explain all these concepts with example. Just listen the concept first. How to find a minus lambda I? And the next concept is, if A is n cross n matrix, if A is n cross n matrix, then a minus lambda I is an nth degree polynomial. Obviously, if you get a minus lambda I, determinant of a minus lambda I, you will get an nth degree polynomial. Okay, so it is called the characteristics polynomial. Okay, this nth degree polynomial is called the characteristics polynomial of the matrix A. So we will understand all these concepts taking very simple example, which will help you to understand these concepts. Okay, so let's take an 2 cross 2 matrix to understand these concepts, and later on I will give you a 3 cross 3 matrix to find its eigenvalues and eigenvector. So let's take a 2 cross 2 matrix as 1 2 minus 3 6. For example, let's take a 2 cross 2 matrix, and the question is your find its eigenvalues and eigenvector. Okay, so obviously as it's a 2 cross 2 matrix, it will have 2 eigenvalues. For 3 cross 3 matrix, it will have 3 eigenvalues, and so on. Okay, so you have the step 1, you have to find a minus lambda I. So your a minus lambda I is nothing but just subtract lambda down the main diagonal. So you will get a minus lambda I matrix as 1 minus lambda, 2 minus 3, 6 minus lambda. So this is your A minus lambda I matrix. So for finding eigenvalues lambda, you have to take the determinant of A minus lambda I and equate is equals to 0. So from this, your A minus lambda I determinant is nothing but 1 minus lambda, 2 minus 3, 6 minus lambda, determinant equals to 0. Just so find the determinant and accordingly find the value of lambda to get the eigenvalues. So if you solve this, you will get 1 minus lambda into 6 minus lambda minus plus 6 equals to 0. So let's solve these equations. This is a very simple way. Just multiply 1 into 6 minus lambda, then minus 6 lambda, then plus lambda square plus 6 equals to 0. So if you arrange in order, you will get lambda square minus 6 lambda, minus 7 lambda plus 12 equals to 0. Just factorize it, you will get lambda square minus 4 lambda minus 3 lambda plus 12 equals to 0. So that implies lambda into lambda minus 4 minus 3 into lambda minus 4 equals to 0, from which you will get lambda minus 4 into lambda minus 3 equals to 0. So you will get lambda equals to 4 and lambda equals to 3. So lambda equals to 4 is your eigenvalue and lambda equals to 3 is your another eigenvalue. So eigenvalue of the matrix A is 4 and 3. Let's see how you can find the eigenvectors. As equation Ax equals to lambda x, you just put x as any column vector, arbitrary column vector x1 x2 of order 2 cross 1 obviously, and put the value of lambda to get the eigenvectors. Okay, so your A is your 1 2 minus 3 6 and your column vector, let's say x1 x2, and your lambda, first put lambda equals to 4 x1 x2. So solve this equation to get x1 and x2 as your column vector. Okay, so if you solve this, you will get x1 plus 2x2 equals to 4x1, which is nothing but your 2x2 equals to 3x1, implies x2 equals to 3y2 x1. So you will get a condition x2 equals to 3y2 x1. So let's, for general eigenvector, so your x1 x2 is your nothing but your x1 and 3y2 x1. Just substitute x1 as any value, let's say k, you will get k 3y2k is your general eigenvector. You can take k as 1 2 3 and so on. So this is your general eigenvector for the eigenvalue lambda equals to 4. You can also find the eigenvector for the eigenvalue lambda equals to 3. So your similarly x equals to lambda x, and your 1 2 minus 3 6 into simply an arbitrary column vector x1 x2 equals to your 3 x1 x2. So if you solve this, you will get another column vector which is x1 plus 2x2 equals to 3x1. So it will give this is 2x2. So this will give 2x2 equals to 2x1, which simply equals to x2 equals to x1. You will get another condition to get the eigenvector. So this eigenvector is nothing but your x1, or you can say simply in general you can put x1 as k. So your general eigenvector will be k. So in this way you can find out the eigenvalue and eigenvector of a matrix A. if whether it is 2 cross 2 or 3 cross 3, the process is same. You can find the eigenvector of a 3 eigenvalue and eigenvector of a 3 cross 3 matrix in this order. So I am giving you a homework to solve for the eigenvalue and eigenvector of a 3 cross 3 matrix. So just given A equals to 1 0 1 2 1 3 0 3 2. So this is a 3 cross 3 matrix, and find its eigenvalue and eigenvector for the matrix A, and this is your homework. And the procedure is very same. In the very next lecture I am going to discuss about the properties and some special way to finding the eigenvalue and eigenvector. Okay, so I hope this video is helpful for you, and if this video is interesting and helpful for you, then please like and share the video, and never forget to subscribe the channel. And thank you so much.